Trigonometric substitutions. In the last video, we looked at the suggested trig substitutions for different forms. We looked at the form a squared minus x squared, a squared plus x squared, and x squared minus a squared. In this video, I'd like to focus on a squared minus x squared. When you have the form a squared minus x squared, the trig substitution that you want to do is x equals a sine theta. Let's look at this problem. It does have the form a squared minus x squared where a equals 4. So we will do the suggested trig substitution of x equals a sine theta, where theta is between negative pi over 2 and pi over 2. And since a equals 4, then what we're doing is we're having x equals 4 sine theta. Once you make the decision of what substitution you're going to do, you just follow your nose. If x equals 4 sine theta, what is dx? Well, dx is just 4 cosine theta, d theta. Next, what about 16 minus x squared? Can you rewrite 16 minus x squared? Well, 16 minus x squared would be 16 minus 4 squared sine squared. And then use your Pythagorean identity. We're now ready to do the substitution. When you do the substitution, it'll look like this. Instead of dx, I have 4 cosine theta d theta. Instead of 16 minus x squared, I have 4 squared cosine squared. Before we do anything else, we really need to simplify our integrand. The first thing is look at that expression in the denominator. I'd like to, wow, that really needs some help now, doesn't it? Do you recall that something to the 3/2 power is the same as something to the 1/2, all of that to the 3rd? And then the square root of 4 squared cosine squared is just 4 cosine theta. So we've done this is hugely better. This is much, much better. And then I just rewrite this as 64 times cosine to the 3rd power of theta. So 4 cosine theta over 4 squared cosine squared all to the 3/2 can be rewritten as 4 cosine theta over 64 cosine to the 3rd, or just 1 over 16 cosine squared. Use that to rewrite our integral. At first, it may seem that all we have done is traded one impossible integral for another, but recall the basic antiderivative we talked about in the previous section. Do you recall that the antiderivative of secant squared is tangent? Well, that's fantastic, because we'll just rewrite our integral as 1 over 16 times secant squared. And so the antiderivative is just 1 over 16 tangent. All right, now we've got a little more footwork to do. We have to substitute back. So we have to remember what substitution we used. We had x equals 4 sine theta. If x equals 4 sine theta, then theta is an angle such that sine theta equals x over 4. Make that triangle. Remember, sine is opposite over hypotenuse, so make up a triangle. Opposite over hypotenuse, And then find that leg. What is that leg? Well, that leg, sorry about that, some sort of technical problem. That leg would be the square root of 4 squared minus x squared. So once we build the triangle, all we need to do is figure out what tangent is. Well, what's tangent? Tangent is opposite over adjacent. Opposite is our angle is x, and adjacent to our angle is the square root of 4 squared minus x squared. So all I did here is I just rewrote 4 squared as 16. So put that into our findings, and we have the answer to our trig problem, and we're all done. Take care, and in the next part we'll do another form. We'll do the form a squared plus x squared. Take care and have a great day.